Hey everyone, this is Martin, and this is part 5, I think, of the devlog C++ OpenGL FPS Engine that I'm doing by following along the course on Udemy. That link is in the description. I'm just going to click on play here because it now takes a little bit of a while to boot, to actually start the application, but you'll see where we're up to, see what we've done. It's been, oh boy, over a week or so, maybe 2 weeks since I did the last video, so I've not made a ton of progress. I've been just too busy with work and life, but hey, there we go. So this is what we've got at the moment. It's not frame dependent because I'm running super fast when it's chugging along, when it's got a low frame rate, because I'm recording the screen at the moment. But we've got bullets. We've got multiple cubes that we've spawned in, or that are part of the scene file. These are, I think in the last video as well, we already had some kind of bullets, some kind of boxes dropping down, but nothing like this. We've also, as you can see, got a shader that allows for different tinting, using the same shader, same material, but kind of different value to each of those boxes for the tint. Level itself, these have got colliders on them, so you can jump on these different boxes or different platforms, go down the stairs, jump on that wall, and you can also hear, you've got steps, bullet sounds, and a jumping sound there as well. So this is, yeah, it's coming together as a little bit of a world now, a little bit of a playable sandbox, something that might be a little bit fun. I can kind of see this being a little bit of a puzzle platformer, maybe might be the direction to go. I'm just thinking of how could it possibly be put together into a game with multiple levels that might be interesting and fun based on what has already been provided within the course, the game that I'm actually building from the course. So we'll see. The other thing that you might notice here is the frame rate being awful with the recording. It's awful when spawning bullets. So if I do that, it's really slow, and as I'm rotating, I'm just flickering all over the place. As I jumped out anyway. Doesn't matter, but yeah, the frame rate is horrible. So that's something to improve at some point down the line. I'm not going to do that now. I'm just going to continue on through the course and see what happens, and then look at optimization at the end. Those bullets have been instantiated every single time you click, though. There's no pooling going on. So that's one improvement right there. So I'm just trying to think back what to look at first, because it has been like over a week, but let's just go back to sort of the beginning. So within the game.cpp file, we're loading the scene.sc file, which is this one here. Now a lot bigger, a lot more complicated. There's a lot more stuff going on in there. So you can see here like the box, which is the front wall. There we go. We've got a mesh component type on that. Again, similar to how Unity works, you have a game object, which is this up here, and then you add components and then fields for those components. In this case, it's a box mesh. Material, setting the path, and then also we've got a physics component on there, and it should be static, for walls. So physics objects react to static objects, but the static objects don't move around themselves, but they are part of the physics simulation. Is there another one in here to do with color? I wonder. I'm just looking at this to give you an example of the boxes. I forgot what it's called now. I know that one of the mesh component itself is called a box. Let's see if we can find it. Components, material. I'm basically looking for a material with a color on it. I've probably gone past one already, but let's go down a little bit and see what we can see. See if one pops out to me as I'm skimming along, because I just wanted to. There we go. I just wanted to show you what this looks like in the scene file in JSON, where we're getting those different colored checkered boxes. So here we're defining the material, and now, well, we already had the path in the other ones, but we've got params now. We're now parsing the parameters of the material as well, and we've said, hey, it's a float 3. The name of that particular parameter is color, and then there's the value from a 0 to 1 range. So let's just try and figure out what might be next. I think I was having a very brief look at this yesterday, and I think what I did come across was perhaps the audio component first. That might be the first one So let's take a look anyway, and we'll see what we can see. Again, this is very rough. The point of these videos really is just for me to kind of cement what I've learned from the other videos, at least to some degree in my own mind, to kind of understand what I've written down and what the heck I've copied, and just helps me learn and remember. So I've got the main player here, and as you can see, one of the components there is an audio component. So with the audio component, we've got a set of fields, or one of the fields is an audio component itself, and then within the audio component an array of WAV files in this case, and the name of that particular audio file. So the way that we're doing that, again, and this is just me sort of recapping, is if I go to need to go to game, and then actually if we go back and then go to scene load, I think it was in here. If I go to definition there, scene.cpp, we're doing scene.load, and then this is where we get all of the parsing magic happening. So contents, loading it as a text file, parsing it into a JSON object here. So there's the JSON, and then down here, where is it? Scene contains a list of objects, which it does. That is that top level again, the sort of top level objects here. I know I mentioned this in the other video, but it's just good for me to recap. I'm just going to drill down into where it gets the audio stuff. So for each of the objects that we've got, we're going to load an object. So let's go to there, and if it defines a type, if the JSON field contains the word type, which in this case down there it does, its player, it should, if I remember correctly, check whether it's a GLTF or just a standard or a custom object here, and then if not, it's just a standard game object. So I think in this case it would be this one, and oh boy, where was it now? Might be a little bit lower. I might just go somewhere else and find where this audio component, load properties. I did take a look yesterday. I think this is it, load game object components. So in this case, the components would be the components array here. So in this case for the player, and then what we're doing for each of the components in the components array, getting the type, and going back to in this example on the player here, with the audio component, it will find that as a type, and that's where it calls into the type creation factory, or the type factory, which is this one. So create a component of type, and then if we manage to create it, then load all the properties. And in this case, this is overridden in the audio component. So here, if I go to audio component.h, load properties, that's animation component. I'm getting the wrong one there. Audio component.h, and load properties. There you go. So it's overridden. So this gets called into the deriving class, which is this one here, and then we go load properties. Does it contain audio? Clips objects. So the audio is the clips. That was the thing. So again, as this was kind of going along, it made a bit of sense to me, connecting it once again to Unity. We have at least from the audio that I've done a while ago, it's been ages since I've done audio in Unity, but an audio listener, which would be, say, for example, on the player, and then the other one would be an audio source, I think it is, and then from on that audio source you'd have clips, and this kind of tied together for me. Again, just putting it together in Unity land. Clips object is basically the audio array here. So let's take a look in scene. And there you go, audio array, name of the audio, and then the path at which the audio lives in the resources. So over here, getting everything from a singular assets resources folder, and then drilling down into the audio folder, and then trying to find these particular files that are named here. Where was we now? Audio. And then from that, we do also have, we've got update, which gets called from the game object, from the main scene.cpp, I think. That's where update gets called, if I remember right, for each of the game objects within the scene. And that will then call, well, as I said, update on each of the game objects. And the game object itself then would call update on each of the components. And I think, yeah, and in this case, each of the components, this one being the audio component, calls update and then plays the loop, whatever it does. So the register audio, probably not going to drill into these too much, but it's kind of standard stuff. What you'd expect with an audio component is we've kind of, we've got audio component play here, we've got stop, checking if it is playing. So fairly standard stuff. I think the library that was used in here was a new one. I can't remember. Mini Audio, I think it was called. We go to third party. Yeah, miniaudio.h. And I think this was loaded through the audio manager.cpp. There we go. So audio manager.cpp. Yeah, mini audio. This is what MA stands for here. Mini Audio Engine. So this is kind of our audio manager here is the wrapper for this mini audio library that we're using. So here we're importing it. I think common.h memory string vector. Play stop is playing. Oh, this is mini. Oh, so this is audio H, not audio manager. Sorry, I was getting confused there. Audio manager, get the audio engine. This was the other one. Set listener position, which was again kind of clicked for me in terms of, yeah, this makes sense. This is how it kind of works in Unity. You got set listener position. This would get called from the audio component, if I remember correctly. So if I go to find references, and sorry, just before I jump off there, we are setting the position of the listener. So you've got 3D audio, I think, spatial audio. So as a rocket whizzes past the player in 3D space, this gets called each frame of where the audio source is, and then the engine responds to that and then either plays it softer or louder. Reverb, I think, potentially is part of what you could do with this engine or this library, or whether it's through the left channel or the right channel. So that's, I think, gets called every frame, if I remember. If I find no references, Audio Manager is the one looking at, and then Audio Manager set listener position. Sorry, Audio Manager. I thought it did. Maybe I'm getting a little bit lost here. I thought it did set listener position. Oh, audio listed component update. There you go. Yeah, that's the one. I don't know why I completely missed that before, but audio listed component. Yeah, so this is the audio listening component is the one that would live on the player, and from that, if I can just find it, actually I'll just bring it up here. Hey, why not? I can do that. This is an absolute potato that I'm running on as well, by the way, guys. So that's why things are very slow with this machine, but it's my slight obsession with making things run on potatoes, so I'm sticking with it. Audio listed component. So this is what would also live on the player as well. So here we go back into scene.sc. There we go. Audio listed component. We don't define any properties with that, or at least not yet, because we're just using it as the singular listener within the scene. There's only one. I think there only can be one in this library, maybe, but so far it's only been coded that way. But there, update is called on this component, which is called from scene.cpp. And then it updates the listener position, which then pumps the mini audio engine to say, okay, now it's at this distance, let's calculate the volume, etc., etc. So not done a lot with audio, but that's kind of the meat and bones of it, of so far, of how this has worked. So the other thing that I just wanted to quickly kind of recap for myself as well is I'm just going to close a couple of these down. The other one is the bullets. I think that was the big one that you probably saw before. Player.cpp, just while we're here as well, I left this open the other day, but I think in update, yeah, when we're doing, if we're checking for walking, and if we are walking on the audio component, we look for a particular sound that we've registered. In this case, it's called step, and we're looping, which is set to true. Else, if we've stopped walking, then we stop the step sound. So pretty standard stuff. And again, this is on the client side, all of this. similar to what we would do in Unity, and again, makes a little bit more sense of me, for me thinking of it that way. So, what was I going to look at next? Bullets. So that's the one. We already had physics. I think I'd already talked about that. I showed that in the previous video. So we had the box dropping from the sky and then interacting with the floor. So we've already got a physics system. We're using bullet physics within this project. So if I go down to third party, there you go, bullet 3-3.25. I don't know a lot about bullet physics really, apart from just what I'm learning throughout this course. But what we are doing is instantiating a bullet whenever we are pressing the left mouse button, if I remember. There we go. So bullet there. We're creating the object, which is dynamic within the world. It's not something that's kind of defined within the scene.sc file over here. This is like, you know, GameObject.new, or where you have a prefab dragged in Unity. Would be a prefab of game object like a bullet. Then you just call, is it instantiate, and then parentheses bullet, and then give it position, etc. So that's what we're doing here. Setting the parent as well. So this one, I believe I've gone over this before. So this isn't something very new. I think the only kind of new thing in here is that we've got this create sphere, which is not a model that is loaded in through an asset file up here, like GLTF. It's not one of these models up here, like the Susan or the machine gun. We are just here creating a sphere at runtime, instantiating it into the world based on like the values that we're passing in, radius, sectors, stacks, and so on. Again, this code was just brought in, sort of copy and pasted, to be honest. I didn't type all of this out, so I don't fully know exactly what's happening here, but it is based on the radius and the sectors, the angle, and setting the position of each of the vertices for that particular quality of sphere that you want to create, and then generate the indices so we're not so that we are reusing vertices when we pass them to the GPU. And then finally the vertex layout, so as it says there, position, normal, UV, and then finally generating the mesh. So that was kind of the new thing in the bullets, and nothing majorly different from the way that we were instantiating cubes before. But again, pretty standard stuff. So bullet game object, we're adding a component, which is the mesh component that we've just created, in this case the sphere. Set the bullet starting position to be in front of the gun, so just like a little offset, and we're finding child by name. Again, stuff that I've seen plenty of times in Unity is, you know, find child or GameObject.find, which we try not to use, so we usually have a reference to this. So either this is something that can be optimized for sure, you know, if this is happening every frame, or not every frame, but whenever we're clicking the left mouse button, we're instantiating the object, and we're using GameObject.find, or not GameObject.find, but in this case we're using where's it gone? Find child by name. Could be quite heavy. Again, I'm going to leave optimization to the end. I'm just going to run through this, but the guy probably didn't know that someone like myself will be running it on a 2014 Dell Inspiron laptop, so it's not surprised that it runs kind of crappy. Adding the collider and the rigid body. So again, this ties it into a bullet physics object. So adding the component, the physics component here, and passing in the defined rigid body and the collider, so that it all becomes part of that physics. I won't go over that part too much really, because I did talk about that a little in another video. But essentially we've got a wrapper for the bullet physics library. So in this case a physics component. I can't remember exactly. Would find a box collider, rigid body, box type static. I think it's actually rigid body. That is which is the actual bullet physics, not the bullet physics object, but within this rigid body we have our bullet physics type. Sorry, not the H1, not the .h file. I want to go to the implementation, definition, load properties, and again, this is just me recapping everything in my brain because there's a lot. This is a lot already, guys. I mean, there's a lot of stuff going on here already. I mean, I've collapsed a lot of these folders, but there's a lot that's been typed out already from this course, so it's really a lot to digest, which is good, which is really good. So creating the rigid body. I think I looked at this just before, didn't I? Set rigid body, rigid body. I won't go into this too long, guys, just bear with me. And rigid body, physics component. Yeah, I mean within here, I've forgotten. There is the bullet physics stuff. Is it a physics physics component? Yeah, this is the component which, again, lives on the game object, and then within that you'd have a type of rigid body. What's definition? BT rigid body. There you go. So, I think it was in here. If I go to definition there, rigidbody.cpp. There you go. BT vector 3. This is part of the bullet physics library. So anything that's got BT on it within this project is a BT bullet physics object. And then I think at the very bottom here, yeah, we say body type kinematic, and body, which is a there you go, BT rigid body. You could probably see that there on the pop-up, BT rigid body, which is bullet physics. So yeah, anyway, rambled on about that a lot. This is just me spilling thoughts out onto a video, everyone. So these ain't very interesting. Just let me know if I am curious, if you find this interesting at all, just boring, or if you're tuning out halfway through, because it is just me rambling and trying to like put all of these pieces back in my head and make some sense of it. So yeah. So what was the other thing? Directional light. That was the other change as well. So where would that live now? It was in the... This is a good question. I don't know exactly. Again, this is me piecing it together. So if I go to... Well, it's definitely within the fragment shader. So we've got shaders over here. We've got fragment shader GLSL. And then I think at the bottom I've made some comments. So ambient light calculations. And then we've got directional light down here. I think it might be a struct. There you go, direction, light direction. Yeah, so that was the difference. That was the other kind of like, not big change, but visual impact change was going from a point light to a directional light. And here, this is the change. So if I go into the scene.sc file again, and if I go to light, I wonder if this, was it within the scene file? But light component, we've got the position. Now I don't know, see, I don't know if direction is taken into account there. Like this is the position, but where's the direction? See, I'm thinking of a directional light here, guys. When again, from Unity Land, the directional light is going to have a direction, but doesn't seem to be in here. So I can't remember exactly how this works, but if I go to light component, maybe those part of the render queue as well. I think we've got camera position. There you go. Light dot direction. So that's the uniform that lives on the shader itself, and this is where we're actually setting that within the shader program on the GPU. Set uniform struct components in the shader using dot syntax. Minus light positions. Where's this passed in, this light? Minus light dot position. So it's just using the light position and the direction. Oh, okay. So that makes sense, of course. Yeah. I think that makes sense anyway. It's basically, say we've got a box in the sort of in the middle here, and then let's say the light is to the upper right. It knows that position of we've got the position of that light here on the upper right, and then we're able to extrapolate the direction by reversing the light position from the, well, in this case it'll probably be calculating the current position of the fragment, and then it's able to figure out the direction of the light. So if I go back into the fragment shader here, so we get this light direction, which is normalizing the U minus U light direction, so the sort of the reverse of it, related to this fragment position. Okay, yeah. Okay, instead of a point light. So yeah, I roughly get it. I get what it's doing. I just kind of, in my mind, there was always a the direction of a light. If you have a light component, there's always like I would have thought it would have been defined as direction here, but it doesn't need to be. It just gets the direction based on its position, and then you can extrapolate the direction. So that makes sense. And I think from here, since we're normalizing it, it doesn't matter. We're no longer doing a point light where there's like an attenuation and it fades off, based on the distance. It's just global direction, So now I don't know if the direction of the light would change based on your position. Actually, let's click on play. I am curious. I'm probably not making a lot of sense here. I'm just wondering if the direction is like kind of infinite, or is it like sunlight? Is it like an infinite sunlight, or is it direction where, say, you've got the light in the center of this arena here, and then that's just going to expand out into all directions? So it is like a point light, but it's like an infinite point light, is what I'm trying to say. And I think I can maybe do it from these boxes here. So the current direction of the light is hard to tell. I can't really tell, to be honest. I think these sides, there you go. So I think these sides here are darker than these sides over here. So the light's probably coming from where I'm stood right now. So I wonder if it's, and it's darker over this side. So the light is probably, again, kind of where I'm sat, or where I'm stood right now. If I do, let me just knock a couple of these over. I'll try and do it softly. So the light's probably right above. There you go. So you maybe saw that one there, that box, as I knocked it up. The light on top there is the shade on top of that box is lighter there, but I'm just wondering if it's, again, I'm wondering if it's like just right above us here, and therefore if I was to move the boxes over to this side, would it get lighter over there? So you can see this right here, what I'm looking at is that box right there, and it's kind of dark on this side. If I was to push that forward over to the other side, as in over there, would it get lighter? Let's take a look. No, okay, it doesn't. So the light must be still coming from, it's kind of hard to tell. Again, I need to get some debug stuff in this. I need to get like eventually some line shaders up there so I can see what's going on, outline shaders, a little bit of debug overlay. I can look into IMGUI for that stuff. I was taking a look at that the other day, and it looks like it's very handy for these kind of like debug related things. So anyway, but we've got a little bit of directional light going on, so that's good. So the whole place is lit up, but basically the direction, as we just said. So cool. All right, well, I've gone on enough, so I'm going to leave it there, everybody. Do let me know if these videos are interesting, useful. If there's anything you want me to talk about, anything within this sort of project so far that you think you want a little bit more explanation, and I'll try and do my best. As I said, this is a course that I'm following in Udemy. I didn't write this code. I'm just copying and following along and just trying to learn. At the end of this, I'll probably try and kind of morph this into an actual game, like an FPS, like I was saying at the beginning, maybe a puzzle shooter, something like, I don't know, kind of like how Portal works with the cubes, something very, very basic, maybe like an old Doom style thing with like level loading, reaching a portal at the end, level 2, level 3, and so on. We'll see what happens. But the link is in the description for that course. It is an affiliate link, so if you do purchase, I get a small percentage, and that just helps support the channel. So anyway, I'll catch you later, guys. Bye.